My final project is on AI emotion detection for therapeutic gaming. So AI has recently become fairly effective in determining human emotion. This is through natural language processing and through facial expression detection. It has also been used to detect emotion for online therapy and to detect emotion in video games, but it was only used to make the game more difficult. But it could be used to create games that assist in or replace therapy. So computer scientists and psychologists have been studying how to use computers to analyze facial expressions. This is not only out of curiosity, but to eventually do some emotion translation between cultures, to assist in the medical field, such as determining patient pain, and in vehicle safety, such as determining if a drunk driver is behind the wheel. There is currently a video game that uses facial emotion detection. It's called Nevermind, and basically what it does is if the player feels stressful in a certain area, it may react in a way to make them feel more stressful, such as flooding the room or something of the sort. Very little research has gone into this technology to actually help the mentally ill. There are two applications that use this, Sparks and Wobot, which use natural language processing to help users with cognitive behavioral therapy. But neither of these use facial emotion detection. So let's talk about why it hasn't been used in games for therapy. Firstly, I believe there's a lack of interest. Game developers usually want to create fun games for entertainment rather than for medical reasons. Because of this, a game would probably need to be commissioned to be created. And it just hasn't happened yet. The other reason is that most people are skeptical about facial emotion detection. Humans have a wide range of emotions, especially because of microexpressions. So currently, AI can detect a smile, but people don't always express feelings through their face. And their face doesn't always say what they're actually feeling. And emotions can be expressed pretty differently across the different cultures. For my brief literature reviews, I had an article called Artificial Emotional Intelligence. It basically discussed how context is super important to understanding facial expressions, and computers don't have this context that people do. One example of this was a zoomed-in picture of a kid blowing out birthday candles. When zoomed in, it looks like he's surprised, but when you zoom out and see that it's blowing out birthday candles, you see that it's not surprise, but probably excitement. Despite this, the article states that computers would have an easier time detecting microexpressions than people. This is because microexpressions occur very quickly, and a lot of people don't notice them unless they're trained. Computers, on the other hand, can compare the face frame by frame and detect these microexpressions. The other article was called Game-Calibrated and User-Tailored Remote Detection of Stress and Boredom in Games. It talked about how traditional emotion detection, like heart rate monitors, are way too invasive. But most people are a lot more comfortable in front of a camera. It also talked about, since not everyone expresses emotion the same way, the application should be more personalized, which can be more easily done in video games. A general emotion detection algorithm would be too broad, so it would be more effective to learn the user's expressions rather than target masses. One of the research papers I read was called Efficient Facial Expression Recognition Algorithm based on Hierarchical Deep Neural Network Structure. This proposed an algorithm that takes an input, performs preprocessing, utilizes the appearance feature-based convolutional neural network, and then a geometric feature-based convolutional neural network, and then uses a weighing function to calculate the final output. So the preprocessing portion of this uses a local binary pattern, which labels the pixels of an image by thresholding the neighborhood of each pixel, and this returns a binary number. The preprocessing also determines the area of the image that contains the face to be analyzed, and then blurs the image to reduce degraded performances. So the convolutional neural network extracts the face's holistic features, and then grabs 9 pixels and compares each of the 8 outside pixels with the inner pixel. For the outside pixels, they're given a value of 1, which means they're brighter than the center, or 0, which means they're darker than the center. They are then connected clockwise and converted to decimal. So you can see the calculation for this here. P is the neighboring pixel, R is its radius from the center pixel, IP is a given grayscale value for the neighboring pixel, and IC is the grayscale value for the center pixel. And then S is the pixel brightness value that we discussed earlier, 1 or 0, depending on its comparison to the center pixel. The neural network then, of course, has a convolution layer with a convolutional operation. This extracts the high-level features from the image. So you can see the equation here. So D is the dimensions of the convolution operation. So in this study it was 2. L is equal to the layer. X is the output of ij in the layer's feature map. Sigma is a given nonlinear function. B is the bias of ij. And WMN is the convolution's weight value applied with each kernel, which is the key to controlling the neuron. After going through that layer, it goes through a pooling layer, which reduces the size of the representation and reduces the amount of computations in the network. It then goes through a dropout operation to prevent overfitting, which ensures that it can be applied to other datasets. It then has a loss calculation applied, and then is finally classified as 2 emotions. After that, we go to the geometric feature-based network, which captures the movements of the landmarks of emotion. These movements are added to the overall features to allow for better feature recognition, are used to calculate the differences between a neutral face and an expressive one, and are used to calculate the best 2 possible outcomes of the geometric feature-based network. After this, the appearance feature-based network results are normalized to the same ratio as the geometric results. After some scaling, they are finally fused to calculate an emotion. And here you can see a visual representation of the algorithm. As you can see, it has the input, which goes to pre-processing through the appearance feature-based network and selects 2 facial expressions, or 2 emotions. Then it meets up with the geometric feature-based network and goes on to combine the top 2, classifies it, and then predicts what the emotion is. So the creators of this algorithm did some experimentation. They used 123 subjects totaling 927 facial images. Each network went through 30 epochs with a 0.01 learning rate for training, and each dataset had 10 sets, 9 for training and 1 for testing. They used a CK Plus dataset and the Jaffe dataset, and they compared their algorithm with the base CNN algorithm, salient feature, which detects the most noticeable features, and the multi-level Haar wavelet, which uses a wavelet function comprised of levels from the face, eyes, and mouth. And you can see in the results that the proposed algorithm was more effective than all of the other ones in both datasets. Even though it's a small percentage, it's very promising, and the accuracy will increase with more training. So the drawbacks of using facial emotion recognition are that currently it can only detect 7 major expressions: happiness, sadness, anger, shock, disdain, and disgust, which, as we all know, is not the wide range of human emotions, and it also can't tell if it's genuine or fake. The problem with using this in therapy is that users would miss out on the much-needed human interaction. Because of this, it could enable users to escape their problems rather than improve their reaction to negative situations. There are, however, a lot of advantages to this as well. So the problem with the inability to detect the range of emotions can be overcome. With some technological advancement and research, it could detect microexpressions. And with the detection of microexpressions comes the ability to detect if the expressions are fake or genuine. So if they see a microexpression that says, hey, this isn't really a smile, it can learn, hey, this person isn't really happy. It could also eventually process this more accurately and faster than most people. The therapy issues could also be worked around. They could assist in therapy to begin with, but not be the only source. This would give developers time to improve upon the methodology. Once improved, this could be distributed to the masses, just like a normal video game. This could be a much cheaper alternative to therapy that many need but cannot afford. Another advantage is that it can be tailored to fit the individual's facial expression. So the algorithm can become very familiar with the user's face and create a personalized therapy experience rather than a general one. So never mind, the game mentioned earlier uses a fairly new product called Effectiva to process the player's facial expressions. Effectiva utilizes a CNN, which was discussed earlier, to detect and classify facial expressions. This includes microexpressions. It has a fair amount of accuracy because of the constant flow of new inputs of faces and expressions from around the world. This allows for testing and improvement in the algorithm, and allows the algorithm to learn a variety of expressions from different cultures, making it more accurate than an algorithm with a small amount of test inputs. This also gives hope for the future. With so many teaching inputs for this, the algorithm will likely become close to effectively detecting microexpressions with little to no error, which is better than a lot of people who are untrained. So the algorithm discussed earlier is a great start to altering gameplay based on facial emotion expression. We can use a camera to analyze images at set intervals, and the computer could learn the user's face and expressions to better understand their personal emotions and needs. This could then be used to alter the game to create a unique therapeutic experience for each person. For example, if a player suffers from anxiety and is anxious in a situation presented in the game could then react by walking them through the steps to overcome the anxiety, or it could alter the environment to calm them down, depending on the type of therapeutic experience. And while there's still a long way to go with facial emotion recognition, especially for use in therapy, this is the ultimate goal.